This is the first one that turns out to be a dy equation, so it's a little bit different from the first three. We take y equals x squared. I drew just the region that we're talking about, so it says y equals x squared, and that between, and I think it gives me a picture in that problem. Anyway, so it gives me this picture, and I am going to rotate it around the or around the y-axis like this. So what it's going to give me is a shape that looks like this. Around the back, the top, and then around the back like that. Maybe more like that. Anyway, so I get this kind of like, I don't know, imagine like a bullet resting on its tip, right? Straight up and down, like perfectly balanced, right? That's kind of what this would look like. Anyway, I'm going to draw my little block like this. I'm going to have discs. Each of these, like this green thing right here, like that would be one disc. So you should see that the height part of the cylinders that I'm going to add up are all y's. So what that means is that we're going to get a dy, and I can also see that because these little gaps right here are y's. This tiny little sliver here. So this is 2, and this over here is 4. So that's going to help me. One of those two is going to be part of the bounds that I use. I know that the radius is equal to this thing right here. So that's my x value. But since I'm doing dy, right, maybe I'll write it out. I want area. Why did I write area? Undo. Volume is pi times the integral, I'll leave it blank for now, of r squared dy. Now, my radius is this x value right here, and I want to plug that in here, but notice here I've got dy. So if I plug in x to here, then I'm not going to be able to integrate with respect to y. But fortunately, I know I have this relationship right here. So if y is x squared, then that means that x is the square root of y. And then what I do is I know I substitute this x with this. So since the radius is x, I can instead say the radius is the root of y. And now if I plug that in to here, I'll be able to integrate it because this variable and this variable will be the same thing. So let's go ahead and do that. I get pi times the integral of the square root of y squared dy. Now I want to fill in my bounds. So the question is, do I go from 0 out to 2 on the x's, or do I go from 0 up to 4 on the y's? So I'm going to go up to from 0 to 4 because 1, I'm working with y's here. 2, you should see that my slices are in that y direction. So I'm going to go from 0 to 4. So that gives me, I'm going to give myself some more space, pi integral 0 to 4 of y dy, which I do power rule. I get y squared, and then I get pi over 2. The over 2 comes from balancing that power rule coefficient right here. And I need to evaluate that from 0 to 4. The 0 plugs in and just gives me 0 squared, right? So actually I'll show it out. I get pi over 2 times, well, 4 squared minus 0 squared. And especially with these, I like to keep all of my coefficients out front if I can. Right, so you should see that this now simplifies to 16 times pi over 2, which is going to give me a final answer of 8 pi.